Hello and welcome to this second episode of All About Nodes in the Glass tutorial series. In this tutorial, I want to show you how you can create a realistic glass wall. And I want to show you some tips and tricks how you can create more details into your mesh. It's easier to use a map to drive the displacement instead of hard model it into your object. So here we are in LightWave modeler, and I modeled one piece of this glass box, and I also created one piece of this frame, and then I used the array modifier to bring up that wall. All right, so here we are in LightWave layout now, and as you can see, the model is imported. I also created a scene for this file. I have a camera, I have an environment light with an HDRI already applied, so we can focus on the glass material itself. All right, so let's open up the surface editor. You can see frame and glass. I double click on the glass, and you can see that we are here with the principled BSDF node. In the last episode, I used the principled BSDF node to create the glass material. The reason for that, I used the principled BSDF node because this node has this transmittance distance. And this value is very important if you want to have a slightly tint to the glass material. But there is another node in LightWave specifically for glass material, and I want to show you this node as well. So in the materials section, you have this dielectric node. Double click, and you can see that this dielectric node comes in with all the nodes that you need for the texture, right? Normal, bump map, bump height, and it has also this transmittance distance value here. It also has the refraction dispersion if you need to. And this node, dielectric node, is specifically designed to create glass material. So let's apply this instead of the principled BSDF. And you already see that the glass material is applied because this node comes in with a refraction index of 1.5. So let's add the transmittance color. So I choose a slight light green color right there. And then if I turn this back to 0, you can see that now we have exactly the same tinted glass that we used in the previous episode. But I set this value to 10 centimeters because I know these glass boxes are 20 centimeters in size. So I use 10 centimeters or 100 millimeters to give just a little bit of this green tint. All right, the second step is I want to push out this flat surfaces here from this tile. I could model that into the model process itself, but then it will be hard baked in the model. I want to keep it procedural as possible, so I want to drive this effect with a map. And the map that I use is this dot node here, right? You can find it by typing dot, and then you get this dot node here, okay? And this dot node is perfect for this. So the only thing that I changed is I changed the fall off and I changed the position and the scale. I want to show you that real quick. So for this, I need the principled BSDF node to visualize what I did. So you can see that every tile has this dot applied and it has a fall off. So where it's white, it pushes out, and where it's black, it stays in place. So when I plug this into the bump map of the dielectric material, you can see now that these polygons are pushed out, and it's pushing out in a curved manner. And this is exactly what I'm looking for. The next thing is I want to have a kind of a distortion in the reflection, because there is no glass surface which is absolutely perfect. You have always a kind of distortion in the glass surface, especially when it is curved. Okay, it's never perfect. So to bring in this distortion, you can use the turbulence noise, right? You can type in here turbulence, and you can choose one of those turbulence nodes and then plug that into the bump. And this creates this slightly distorted surface on the glass material. The only thing I did here is I changed the bump amplitude so it's not so strong. So when I set this to 100, you can see that the distortion or the bump distortion is very strong. So I set it to 30%. So I have just a little bit of distortion here in this field. All right, so this turbulence noise. So by using this turbulence noise to get this distortion, it looks already good, but it does not look realistic. So the reason for that is that the distortion is not from a real glass surface. It's a turbulence noise, okay? It's a procedural turbulence noise. You can change it, you can play around with settings to get closer to a realistic distortion of the glass surface, but it will be way better to use a real glass distortion material. And this is one of those. It's come from Polygon. It's part of a glass material, and this is a real glass distortion pattern. To show you the difference, I plug that into the normal, and you can see right away it looks more realistic. The distortion is from a real glass surface. Okay, and combined together with the bump to push out the surface, you can see that now in combination it gives you a realistic look of that glass surface. So the next step is, and if you know me, I always like to put imperfections on my surfaces. Okay, so and glass is not different. No glass material and no glass surface is perfectly clean. It has always a bit of dust, a bit of scratches, water droplets maybe, and those imperfections we want to add. Okay, so I have here a map that I used from Grayscale Gorilla. It's called Strains 50, which has got these splotches and these water droplets. And then another imperfection map also from Grayscale Gorilla, which is called Strength 28, is the same strength texture that I used in the previous episode on the glass material. So now we want to combine these two imperfections on this surface. So how we can combine two Luma output ports? We need an add node, and it's called the scalar add node, because the scalar add node has two green input ports. So now we can plug the output to the input, and then we can drive this into the roughness. And right away, you can see that these imperfections are applied to this window field. So the last step that I do here, and it's the same step that I did on the first episode, I use this strain material and I use the bump of it to bring out these water droplets just a little bit out, so they are three-dimensional. So I need this bump, but I already have a bump map here, right? So how we can combine two bump maps? Well, it's the same node, it's the add node, but this time we use the vector add. You can see that this vector node has 2 blue inputs. So now we can add one bump with the other and bring this bump into the bump itself. All right, and now you can see that this water droplets and water strains has a bit of depth, and it's creating a more realistic looking feeling. If this strength are too much for you, you can easily go into this map and change the values here, right? You can change the brightness or the contrast, and you can adjust how much of those strands you want to see in your surface. So you can change these values until you find a setting that is pleasing for you and it shows the details in the surface, but maybe not so strong. And I do the same for this one. I just dial it down so that it might not appear that strong. All right, and this looks pretty good to me. And that is the end of this tutorial episode. I hope you learned something. I hope you like the content. And if you have any questions, please let me know in the comments or join our Discord server. The link is underneath this video. Join the Discord server, chat with other artists, or if you have any questions, post it there. If you have any tutorial requests, you can post it there as well. It's the direct connection to me, and I try to respond on every request that I get. It depends on how much time I have, but I really try to respond to every request and question. Please like, comment, and subscribe. Help me to push this channel out and to grow. And as always, have a nice day, evening, in what time zone you are. Enjoy. Thank you, and see you next time very soon. Bye everybody.